Hey devs, and welcome back to week 7 of our mobile application development with Android course. This week we're continuing to build on our ongoing weather application, and we'll be actually loading real weather data using the Open Weather Map API, and we'll be using a library called Retrofit, which is very popular in the Android world. We'll be using that library to load the data from the Open Weather Map API, bring it into our app, and then we'll be updating our UI to display that real weather information. So as usual, we'll start off with the lecture, and then we'll jump into the code at the end and walk through the updates for this week's assignment. All right, let's go ahead and jump into our lecture then. As usual, we will start off with the project demo and give you an idea of what we will be building on this week and what concepts we'll be exploring. Then we're going to dive into how to make remote network requests on Android. Specifically, we'll be loading remote data from the Open Weather Map API. Then we're going to take a look at how to load remote images as well, and at a couple different libraries we can use to load those remote images and place them into our UI efficiently. So for our week 7 project demo, what are we going to be building? Well, we're going to be focusing on 3 main things. We're going to be looking at how to load current forecast data from Open Weather Map API so we can actually see what the weather is in our entered location. Then we're going to load the 7-day forecast data from Open Weather Map API, again from that same entered zip code location. And then finally, we're going to load and display forecast icons from a remote URL so that our list items actually show icons relating to what that current weather looks like. So before we jump further into the lecture, let's jump over to our emulator. And let's just take a look at what that is looking like. So here I have opened up my application and I have already entered in a zip code previously. You'll see that because I've loaded the zip code previously, it's actually remembering that on load. So that's going to be the first step this week, is to remember the zip code when we enter it. Then when we open the app, it's going to load data from the Open Weather Map API. You see here, I've loaded the weather data for Seattle, and it's giving me the forecast for the next week, and it's also including icons for each of those forecast items. If I go in here and change my zip code to something else, go ahead and click submit, we'll see this time it loads new data. And we have a different forecast here, and you can see some of the different icons available. If I close my app and open it up once again, we see here again, it has remembered that previous location, and we automatically are shown forecast data when we open up the app. So that's what we will be working on this week. Now, the key part of this, or the biggest change here, is learning how to make network requests from our Android app and to hit a remote data source. So the key question here is, how do we load data from a remote data source? And maybe before we even go too much farther, what is a remote data source? So to help us in the loading of this data, we're going to be using a specific library that's extremely prevalent in Android. It's pretty much an industry standard. It's called Retrofit. And Retrofit is an HTTP client for Android and Java. And it's an open source library from Square. And Square is, again, super prominent in the industry. They put out many, many great libraries, Retrofit being chief among them. So now back to our idea of loading remote data and even what is a remote data source. So a remote data source is really just any server out there, any type of mechanism that can serve out data to you. So that could be something like a server running on Amazon Web Services or Google Cloud Platform or Heroku. It could be something like Firebase serving out data to you. It could also be a static JSON file hosted on your local machine. Basically, it just means any data that's not really pre-packaged with the app. And in modern apps these days, loading remote data is pretty much essential. It's pretty much any app is going to have to load some type of dynamic data from some type of source. And we really have this two-way street here. We have requests going out to the remote data source. And the data source then sends us back responses. And it's this request and response pattern that Retrofit is really, really well suited to help us with. It simplifies both ends of this process and makes consuming responses and making requests very straightforward for us, whether you are in the Android world or the more generic JVM world. And now when we're working with Retrofit, there's sort of three key concepts that we'll be taking a look at. To define the API interface that we'll be calling, so this is, think of as the functions of the remote server that we'll be calling. We will define a simple Kotlin interface or Java interface if you were working with Java. This interface will define the methods that we can call, and these methods should correspond to different API endpoints on the backend. We'll then use a class called Retrofit Builder. The Builder class will generate an implementation of our API service. And it's this generated implementation that we can use to actually interact with that remote service. That generated class handles a lot of the boilerplate stuff that we might otherwise have to write ourselves. It knows how to do things like add headers for us, deserialize things, or gives us a place to customize how we might deserialize things. It really does a lot of things for us, and it's largely why it's so popular to use Retrofit these days. And then lastly, we have this class called call. And call represents the request. And we can use call to make either synchronous requests for data or asynchronous requests for data. And we'll take a look at the difference between those in a little bit. So the first thing that we need to do when we are getting started with Retrofit is define the model. And this is the model for the data in the response. So this is an example of the current weather model that we'll be using this week. And this is what we will use to capture the current weather data for the location we have entered. Next up, we need to define our interface for working with that backend. So we're going to be creating an interface called Open Weather Map API Service. And on that, we'll have an interface method that looks like this. It'll be called current weather. And we'll have some annotations here. The get annotation is signifying that this is going to be a get request. If you're not familiar with HTTP or a simple like REST request, get is basically a simple request that says, hey, I'm going to ask you for some data, and then I want you to hand me back a response. Each of the query param annotations here signify a different query parameter in the request. All of these query properties here, the zip code, the API key, and the units, those will eventually get appended to the path specified in the get annotation so that it matches the path in the comment at the top of the file here. So ultimately, we want to hit the API that is at http api.openweathermap.org/data/2.5/weather. So all of that is essentially the Open Weather Map's weather endpoint. Everything after that are the query parameters that we're going to specify. So in this case, I have specified a query parameter for 98119 zip code. I want imperial units, and then we have to pass an API key to differentiate our app from someone else's. Once we have our Open Weather Map service interface defined, we can use that Retrofit Builder class to create a Retrofit object and then use that to create that generated instance of our API class. it's in this builder process where we also have an opportunity to customize how our requests will be made. So in this case, I've specified a base URL of api.openweathermap.org. I've then added a converter factory. This is a converter factory from a library called Moshi, which basically does JSON serialization, and it works particularly well with Kotlin, which is why we're going to be using it this week. But that'll essentially make it so we can take the JSON response from the API and then map it into those model classes that we saw a couple of slides ago. Once we have that generated implementation of our API service, we can make use of it like this. So in this case, I'm calling weather service.currentWeather. I'm passing in a zip code, an API key, and the units, and I'm getting back a call object. We can then use this call object in an asynchronous fashion by calling enqueue and passing in a callback. What this will do is load the data on a background thread and then call us back on the main thread, and it'll let us know if there was any type of failure, or it'll give us back the response that we got back from the network. Then we can get a hold of the response, check if it's null or not, and then do anything else that we need with it. Now, before we move on to anything else, we really should take a closer look at threading on Android. So as a quick refresher of threads in general, a thread is an independent path of execution within your code. Within a thread, instructions are run one by one. So these instructions are literally just lines of code. The same way we think about stepping through our code visually, we might look at line 10, line 11, line 12. That's very much the same way in which a thread is going to run each of those instructions within your code. So as we're running these instructions one by one, an instruction can't start until the previous one is finished. In this case, the second instruction is considered to be blocked by the first. Now in Android, this poses a particular challenge. Android apps run on what is called the main thread by default. That means by default, everything you do in your app runs on the same thread. So all of our activity on create function, on resume, on start, everything we've been doing is all happening on the main thread by default. The challenge is that drawing the user interface also happens on the main thread. And to help ensure performance and smooth UI, that main thread is going to draw that UI every 16 milliseconds if it can. This means that we have to do all of our work, all of the responding to any type of event, click, interface, loading data. We need to make sure that every 16 seconds our work is done so the main thread is free to draw the UI. If we block the main thread, we will cause slowdowns in our app and jank in our UI. You might see stutters. You might see the UI completely freeze. And in fact, if you block the main thread for too long, you'll receive an activity not responding dialog in your app. These are also what's known as ANR dialogues. And these are bad. These are things you really want to avoid. So it becomes really, really important in the world of Android to avoid blocking the main thread. To avoid blocking the main thread, then, any long-running task should be run on some type of a background thread. And there's a lot of different options available to us for running things on that background thread. We have threads themselves. We have executors. We have runnables. We have abstractions like async task, high-level libraries like RxJava, coroutines, work manager. And honestly, we haven't talked about most of these, and I don't want you to worry about most of them. Some of them have their place and are still popular in the world of Android. Others are maybe more deprecated, not used as much. Not important so much for our task right now. I just want to illustrate that there's a lot of ways to go around this because it is a complex problem. For us, thankfully, and for this week's assignment, we can rely on Retrofit because Retrofit has mechanisms for handling this built into it. The Retrofit call class enables us to asynchronously load our network requests. We can pass the callback to the request The work will be done on the background thread for us, and then we will be notified on the main thread. So this really takes care of most of the work to make sure we're not blocking our main thread and that our UI stays nice and responsive. So just to refresh and to kind of bring it back, as we saw before, we're creating our call class to our weather service in this example here. When we call in queue, we're then passing in that callback. So the work of enqueue is going to say, hey, some other thing on a background thread, make this API call to load the current weather. We're going to do this work on a background thread, and when we're done, we're going to take this callback, call it on the main thread, and let the caller know that we either have the weather or there was some type of failure. So this type of callback pattern is very common in many types of libraries, and it's a good way to help ensure that we're not blocking the UI or just any other thread in general. So now, as I mentioned, we're going to be looking at Open Weather Map API this week. So I want to take just a second and examine that a little bit more. So you see here, this is a picture from the API documentation for Open Weather Map. And they have a number of different ways of getting data. Each of these, it can be considered to be its own endpoint. Essentially, this is a different remote function or remote URL that we can call, and will hand us back different types of data. And each of them will also take different types of data as parameters, so we can customize the request and get custom responses back. We're going to be working specifically with the current weather data endpoint and the one call API endpoint. So the API itself can be found at openweathermap.org/API. That's where you can find more information about it. And in the demo later on, we will actually be showing how to create your free account and get a hold of your API key. The two endpoints we're using, one is /weather that will return us the current weather. We'll also be getting a lat-long location from that endpoint. And then we have the one call endpoint, which is kind of their new one-stop shop endpoint that can return a lot of different things, but we're going to be using it to get a hold of the 7-day forecast for our specified location. So now we've talked about loading remote data. Another type of remote data that we might have to load is actually images. App resources can't be packaged with all app resources can't be packaged within an app. Resources today are too large. They take up too much room. Designs might need to change. We have too much dynamic data. We just can't load everything into the app. A perfect example of this is social media. Social media is continuously dynamic. And if people on, say, Instagram are posting new images, there's obviously no way for us to package those with our app. So we have to be able to load those images into our app and display them efficiently. Now, thankfully, again, in the world of Android, we have multiple open source libraries to help us do this. The three kind of most popular examples I've run into include Glide, Picasso, and a more recent one specific to Kotlin called Coil. So we're going to actually be using Coil this week because I think it has the easiest setup. And really, this is all we need to do to get a basic implementation of loading an image from a remote URL. Now, Coil and all of these image loading libraries can do other things like specifying placeholders, specifying animations between the placeholder and the loaded image, and error icons, and all that kind of fancy stuff. But for us this week, all we need to focus on is this functionality right here. We're going to build up a URL to get the icon for each of the forecast weather icons. And then we're going to pass it into this call and load that icon into an image view in our list items. And with that, it is now time to jump over to Android Studio, and we will start work on our week 7 assignment demo. Okay, now that we're back here in Android Studio, we're going to first start off by updating how we pass the saved zip code to our different fragments. And to do that, we are going to implement a means of saving the zip code when we enter that zip code into our location entry fragment. So the first thing we're going to do is come to the left-hand side of our screen. And we're going to navigate down to our package where our code resides. And we are going to right-click on our package name, go to New, Kotlin File or Class. And we're going to create a new class called Location Repository, and then hit Enter. So in that class, we'll start off by typing class location repository. And to implement the saving of the zip code, we're going to use shared preferences once again. So to do that, we will first need to make sure that our class takes a reference to a context, because as you remember from our previous implementation with shared preferences, you need a context to get access to the shared preferences. Next, we're going to create a property to store those preferences. So we'll type private val preferences equals context dot get shared preferences. We'll pass in settings for the file name once again, and we'll pass in context.mode private. Next, we're going to create a sealed class to represent different types of locations within our app. So to do that, we will come a couple lines above location repository. We'll type sealed class, and we'll name that sealed class location, and then we'll add the open and close curly braces. Now within that, we're going to add one specific implementation of this location type, and that's going to be a data class, and it's going to be called zip code. That zip code type is going to take a single property, also called zip code, of type string. And then this class will extend the location class. So we've created this new sealed class hierarchy of location that enumerates all the different types of locations we handle in the app. And then we've added zip code as a specific type. Now for now, that's all we're going to have. But by the end of the course, we should also be able to support lat long locations as well, taken from the GPS. And so by implementing this now, it gives us room to grow into that added implementation down the line. So now we need a way to expose this saved location to other interested parties within our app. And so we're going to do this with live data like we've done with our other repositories. So we'll create a private val underscore saved location property of type mutable live data, which will give us a location. If you get the little red underline here, it'll just need to be an import. So you can put your cursor under the red class name and hit Alt Enter, and that should do the import for you. Once we've defined our property, we need to assign its value, and we will create a new mutable live data. And now, like we've done before, we want to create the publicly exposed version of this live data. So this time will be a public val saved location. Its type will be a live data of location. There we go. I'll import the live data class, and I will assign this to saved location. Now, if you don't remember from our previous implementations, this will let us change the saved location internally by referencing underscore saved location, and then external parties can observe the value of saved location. Anytime underscore saved location's value changes, saved location will also change. By having these two separate properties here, it prevents outside parties from manipulating the values stored by saved location within this class. Now, we want to create a way to save the location when we get it from our location entry screen. So we're going to create a new method called fun save location, and that's going to take in one of our new location objects. So now we're going to do a when statement here, and we're going to pass location into this. We're going to say when location is location.zipcode. We want to save that location value by typing preferences.edit. This starts a new edit preference session. Put string. And for now, we will type key location. Actually, we're going to type this as key zip code. There we go, key zip code. And then we will type location.zipcode. And then we'll hit apply. So what this will do is make sure that anytime we call save location, it's going to save that location to shared preferences. Now there's one small little update that I want to point out here that we could make. So here we have defined key zip code as an inline string literal. However, if we wanted to reuse this string anywhere, if we had to manually enter it every time, it would be error prone. There's a chance that we could change it without meaning to. So we're going to create a constant to store this. In Kotlin, you can create top level constants pretty easily. So we're going to come outside of our location repository class, but still within the same file. And we're going to type private const val key zip code equals key zip code. So what we've done here is we've defined a private top level property. So it's only available within this file, which is exactly what we want. It prevents other people from using it. We've defined this as a const because this value will not change. So at compile time, we know what this value will be up front. And then again, it's a val for the same reason, because we're going to assign this value once and it's never going to change. So now we can copy key zip code and use that down here in our save location method. So now this has given us a way to save the location, but we still need to know if that location changes so that we can notify other callers. And the reason this is important is because this location could change because other instances of this class maybe are going to change it, or maybe something on disk could even change it. So we want to listen for updates to that so we can notify our observers. Now there's a pretty easy way we can go about this. So we're going to come back into location repository. We're going to go kind of below our properties a little bit, and we're going to create what's called an init block. An init block is very similar to a constructor body. Basically anything inside the init block will run when this class is created. And within this init block, we're going to add a shared preferences change listener so we can listen to changes in this value. So we'll type preferences dot register on shared preference change listener. And we want to make sure that we're referencing the lambda here. Now within our lambda, we're going to have two parameters available to us. The first one is the shared preferences, and the second one is the key for the preference value. So for us, we want to check if key does not equal key zip code. We can go ahead and return from this lambda listener. However, if it does equal key zip code, then we're going to go ahead and get access to that zip code. So we'll type val zip code equals preferences.get string key zip code. We will pass in a default value of just an empty string. And then on the next line, we'll check if zip code does not equal null and zip code dot is not blank. We will go ahead and then update our live data. So we'll say underscore saved location dot value equals, and we will create a new instance of our zip code location class by typing location dot zip code and passing to the constructor that zip code value. So if we take just a closer look at this again, when our location repository class is created, the init block is going to be run. We will register a shared preference change listener so that anytime shared preferences change, we'll get notified. We only care about changes to the location setting right now. So if the key does not equal key zip code, we'll return and just ignore it. If it is the zip code key, then we will get the current zip code value. And if it's not null and it's not blank, meaning we actually have some saved data there, we will go ahead and forward that on to our saved location observers. Now there's one other small change that we need to make here. After we have registered our listener, we want to actually notify our observers of whatever the current value is here. So one easy way of going about this would be to once again get the current zip code value. So here I've done a copy and paste, and again I've defined a zip code variable and I've gotten that value. And then also once again we could do the same checks. If zip code does not equal null and it's not blank, go ahead and notify our saved location live data. Now, as you may notice here, we are now duplicating that logic in a couple places. So let's clean that up a little bit. We'll come down to the bottom of our class, and we're going to create a new private method by typing private fun, and we're going to call this broadcast saved zip code. And then one more time, we're going to do a copy, a delete, and then a paste into this new broadcast saved zip code method. And then back up in our init block, we will call broadcast saved zip code at the end of the init block so that we send off that initial value. And then within our preference shared preference change listener, we can also replace it and pass in broadcast saved zip code. So now our init block is much smaller, and we've consolidated this logic within broadcast saved zip code. So now when we create an instance of location repository, it will look up the current value of the saved zip code, broadcast that zip code if there is one, and it will listen to future changes in that zip code. So now we're ready to actually use this location repository. And so to do that, we're going to open up location entry fragment. At the top of location entry fragment, we are going to create a new property for a location repository. So type private val location repository. Actually, excuse me, it needs to be a private latent var location repository. There we go. Now down here in our onCreate view, we will go ahead and create our instance of location repository. So we can type location repository equals, and we'll create a new instance of location repository and pass in context using the require context method. Then in the enter button, after the navigate up call, actually, excuse me, before the navigate up call, we can type location repository, save location, and we will create a new instance of the zip code location class. So location dot, there we go. So I typed location. Now it's asking me to import that location class. Now I can go ahead and type zip code and pass in the zip code string that we had previously. So now anytime we enter a new zip code, we're going to save that in our location repository. Now we want to open up current forecast fragment. And we are going to also create a reference to a location repository. So we will do private latent var location repository. Then down towards the bottom of our location repository class here, we are going to initialize location repository by saying location repository equals location repository. And once again, we'll pass in require context to make sure we have that context at runtime. Now we want to observe changes to the location. And so to do that, we're going to first create an observer by typing val saved location observer equals observer of location. We're going to create a lambda, and the parameter name will be save location. Now we can say when saved location. Within this when statement, we can type is location.zipcode. And then we will, anytime we get a zip code, we will type forecast repository dot load forecast saved location dot zip code. Then now right below the observer, we will type location repository dot saved location dot observe. For our lifecycle owner, we will pass in view lifecycle owner, and we will pass in our saved location observer. And so now, if we look right below that, previously when we were loading the forecast as soon as the class, or as soon as our view is inflated, we no longer want to do that. So we will remove that. So now, when we create current forecast fragment, we are going to listen for changes in the saved location value. And anytime we get an update in the location, we will refresh our UI. All right, now that we have updated current forecast fragment to take in the current saved location, let's update our weekly forecast fragment. So we're going to start by just closing out all these files. And then we're going to open up weekly forecast fragment. And now, similar to current forecast fragment, we need to create a new private latent property for our location repository. So we'll type private latent var location repository. We will then, very similarly to before, we'll come down and remove this old call to forecast repository.load forecast, because we're going to update this to respond only to changes in the location. So let's start by initializing location repository. Location repository, we'll pass in required context. Now, just like in current forecast fragment, we will create an observer. So we'll call it val saved location observer equals observer of type location, and we'll pass in a lambda. The lambda parameter we're going to call saved location so it's more readable than just using it. And again, we'll use a when expression here. When saved location is location.zipcode, we're going to call forecast repository dot load forecast, and we're gonna pass in saved location dot zip code. The reason we keep using when expressions here is because when expressions can enforce that you handle all types within a sealed class hierarchy. So by using when expressions, it helps us in the future if we start adding different types of location we want to handle, because it'll enforce that we actually handle those locations in these when expressions. So now below our observer, we need to actually observe the value. So we will type location repository dot saved location dot observe. We'll pass in view lifecycle owner and our observer. So just like current forecast fragment, weekly forecast fragment will now refresh its UI anytime the saved location changes. So now, as we start thinking about moving more and more towards loading real data, we're going to need to refactor our forecast repository. So I'll close weekly forecast fragment, and I'm going to open up forecast repository. And if you remember from our previous lectures, in forecast repository, we currently just have one main method. We can just load a generic forecast. So we're going to want to update this to be able to differentiate between the current forecast and the weekly forecast. And so we're going to do this very similarly to how we've done before. So just like we have this live data for weekly forecast, we're going to create one for a current forecast. So we'll type private val underscore current forecast equals mutable live data of type daily forecast. So there we've defined our mutable live data that will pass a daily forecast value to observers. And now we will create the public version, which is val current forecast of type live data daily forecast equals underscore current forecast. So now we're going to come down to our load forecast method. Now, if you remember, load forecast is currently loading 7 values. So that really is kind of mimicking the weekly forecast behavior that we want in the end. So we're actually going to rename this method to load weekly forecast. And then we're going to create a new method by typing fun and calling it load current forecast. And now to start in load current forecast, we're basically going to generate one random daily forecast item. So we'll type val random temp equals random dot next float dot rem 100 times 100. So remember, this will give us a random value between 0 and 100. And then now we'll type val forecast equals daily forecast. We'll pass in a new random date. We'll pass in our random temp, and we'll call get temp description, and again pass in random temp. And then we'll go ahead and update our live data. There we go. So now we have separate methods for loading the weekly forecast and for loading the current forecast. So we're going to need to update our fragments then to account for these new methods. So first, let's open up weekly forecast fragment. So you see here, when we try to call load forecast, we are getting an error. So instead of load forecast, we're going to type load weekly forecast. And that should be pretty much it. We didn't really change anything else with this method for weekly forecast. Now let's open up a current forecast fragment. Here we actually have changed a little bit more. If you look at our observer, where before we had a weekly forecast observer, we now really want to update this to just be a current forecast observer. So we're going to delete this current observer code, and we're going to update it for the new method. So we'll create a new observer first, and we'll call it current forecast observer equals an observer of type daily forecast. Within our Lambda, we will name the parameter forecast item. And then we're just going to leave a comment here telling us that we are going to update our list adapter. And then we're going to type daily forecast adapter dot submit list of forecast item. So basically our adapter expects a list right now, and we don't want to update our adapter quite yet. So we're going to take in our single forecast item for the current weather and just create a list out of it. And it'll just be a list of type 1. So our UI won't need to scroll or anything. Now, once we've created our observer, we can type forecast repository dot current forecast dot observe. We'll pass in view lifecycle owner and our current forecast observer. And then down below in our saved location observer, whenever we get a saved location, instead of calling load forecast, we want to call load current forecast. And you see we have an error here. This is because in our load current forecast method, we didn't pass in the string yet because we're not really using it, but we are going to eventually. So we're going to come back to load current forecast and just go ahead and add a property called zip code of type string. So now if we go back to current forecast fragment, we should see that our call to load current forecast fragment is correct. So now let's just check on what the app looks like at this point. We'll go ahead and click run. And we will switch over to our emulator. And shortly, we should see here that we now have a current forecast fragment that shows one item and a weekly that shows several. So here we are blank to start and blank to start. So this is expected because we have no saved location yet. So now let's go ahead and enter a location. 1, 2, 3, 4, 5. We'll click submit. And now on the current weather screen, we see one item. And on the weekly screen, we see multiple items. And now if we close this and rerun it, this time we immediately see data because our location repository saved that data and then immediately served it out to us when we started the app up again. So this is one reason why this repository pattern is really helpful to us. We can save out the data, we can manage how data is returned, and we can do things like respond with cached data as soon as the class is loaded. And then if we wanted to, we could load new, fresher data in the background and respond when that data comes back. So it lets our UI be more responsive and even can really help us build offline first UIs and applications that don't need any type of internet connection. All right, so now we are saving our location data when we update it. And we are also now using different repository methods to load our current forecast and our weekly forecast. Now it's time for us to actually start loading real data using the Open Weather Map API. So what we need to do now is go to Chrome and go to your search window and search for Open Weather Map API. And you want to look for the first response here. So it should be openweathermap.org. Go ahead and click on that. And it should bring you to the API page here. If it doesn't, it should be at openweathermap.org/API. Now, as we mentioned earlier in the lecture, these are all different endpoints available from the Open Weather Map API. And now to use any of these, although there's a lot of functionality for free, you do need to create an account. So first, go up to the sign in page in the upper right here, click sign in. If you don't have an account, you can click create an account. And it's going to ask you to specify a username, an email, and then a password, and then a couple privacy GDPR type things here. Go ahead and fill this out and create your account. And then after a few minutes, you should get an email asking you to confirm your account. So once you've confirmed your account, you'll want to come back to the sign in page and go ahead and sign in. If it prompts you for any of this, just go ahead and click cancel. And so then it should send a confirmation. And like I said, you check your email, look for the confirmation. So the important thing here then is to come to API keys. Now, typically you don't want to share your API keys. As this is just a demo, I will have to make sure and go back and delete this key later. But this key right here is what you will use to authenticate your application with the API. So this is essentially kind of your unique identity to the API. And it's how they will monitor what functionality you have access to and how many network requests you can make. So if you want to test out that your API key is working, go ahead and just copy it. Then come back over here to API. Go to the current weather section, click on the API doc. Now you'll see that it has some sample requests here. So we could grab one of these sample requests. And actually, let's do this by zip code since that's what we've been doing. So come down here and we'll grab this sample request for a zip code API to load the weather. And we're just going to create a new tab and we're going to drop that into the tab for now. We're not going to hit enter. We're then going to go back to our API key. We're going to grab our API key. Now we're going to come back over to our other tab and we're going to paste our API key at the end of this URL after the API key query parameter. And then we're just going to delete the country code query parameter. And for a zip code, I'll enter a Seattle zip code of 98119. And now, if I hit enter, you probably will see something like this. This is going to say invalid API key. And the problem here is that it takes a little bit of time for your API key to become valid. Now, what can you do about this? There's not a whole lot you can do. What you'll have to do is just wait. Hopefully it doesn't take very much time. But once you do sort of get the valid API key and it's authenticated, initialized with their system, the way you'll be able to tell is that this will return a valid response. So I will now switch to a different API key that I already have prepared. And now this time when I hit enter, we'll see that I get this big block of JSON back. Now, if you want to actually visualize this a little bit more easily, we can just copy this JSON response. I'll open a new tab and I'm just going to type JSON viewer. And I often just use this first option here, online JSON viewer. I'll click on that, paste that into this text tab, and then I'll look at this viewer tab. And so this is what the response looks like when we use that current weather endpoint. We can see that it hands us back coordinates that include a lat/long location. We get this list of weather objects back that tell us it's rainy with moderate rain. We get this main object that includes temperature, the feels like, the min max. Notice by default that comes back in Kelvin. We can specify the units for Celsius or imperial if we want to get Fahrenheit back. So this basic workflow of looking at the API, looking through the API documentation here, copying a call, pasting it into a tab to test it out with the parameters you need, and then inspecting the response, that's a pretty common workflow, and that's a good way for us to get started. So if you're having questions on what the response should be, you can do this, or you can look at the API documentation, and they should also have sample responses for you to take a look at. Okay, now that we've explored the endpoint a little bit, let's close these tabs. And now we want to take a look at Retrofit because we want to start integrating a Retrofit so we can actually use these endpoints. So go to your search tab and just type for Android Retrofit. And you should see square.github.io, Retrofit Square open source. So we're just going to click on that real quick, just to highlight that this is the Retrofit page. And there's a great little intro here and some API documentation to give you a great second resource here for how to start integrating Retrofit into your application. So in particular, I'm going to scroll down to the bottom here, and you'll see that it gives you an example, a Gradle implementation for how to pull that into your build.gradle file. It just will ask you to insert the latest version. So I'm going to copy that, and then we're going to go back over to Android Studio. All right, so here we are in Android Studio, and I'm going to scroll to the left, or scroll to the bottom down here in the left, go to App, Build.Gradle. And in my dependencies block here, I'm going to paste in this dependency that we just grabbed from the Retrofit documentation. Now, I already looked this up before, and version 2.8.2 should be a good current version of Retrofit for us to use. Now, that's the base Retrofit implementation. There's one other dependency that we want to pull in right now. So I'm going to type in, again, implementation, add the quotes here, and this time it's going to be a library called converter-mashi. So this time we'll type com.squareup.retrofit2 converter-mashi and this is version 2.5.0. So this Mashi converter is going to help convert our JSON responses into nice Kotlin idiomatic data classes for us. Once we've done this, let's just do a quick Gradle sync to double check that these dependencies have been declared correctly. It looks like that all worked. So now there's two other little configuration things we want to do before we start implementing our Retrofit endpoint. So we want to go to the left-hand screen over into the project pane again and open up the Android manifest XML file. And we need to do two things. We need to add a permission. Now, we haven't talked much about permissions. Permissions basically tell the system that the user has granted this app permission to access certain functionality. So in this case, we want to add a permission for using the internet. So to do this, we're going to type an angle bracket, and you should start to auto-populate the options for you. So in this case, we see this uses permission tag. I'm going to hit enter. And then again, immediately it's going to suggest that I use the android.permission.internet permission. And then I'll just close out that XML tag. So by adding this, uses dash permission, android:name equals android.permission.internet, we've declared that this app will use the internet permission. Now we'll talk more about the permissions model in a future lecture, but by default, this permission will be automatically granted. There's kind of what's known as sort of standard permissions and then unsafe permissions. Unsafe permissions need to be requested. Standard ones like internet are just kind of granted by default. If we hadn't have added this permission, then the first time we tried to access the internet, our app would have crashed and it would have said, hey, you don't have the internet permission. So I've saved us that crash. Trust me, I do it all the time. I always forget this. So hopefully you can learn from my mistakes and add the internet permission. The next thing that we need to do is go down to our application tag here. And we're going to add a new line here. And we're going to update this property, Android: uses clear text traffic. And we're going to set that value to true. Basically, this is a security thing where newer versions of Android want you to try and use secure HTTPS traffic anytime possible. This is a good idea. However, for our process, we are not going to be worried about that right now, and it's outside the scope of this course. So by adding uses clear text traffic, we won't run into any issues. So now, finally, we've added the retrofit dependency, we've updated our permissions, we've updated clear text traffic. Now it's time to finally start integrating retrofit into our app. So let's go ahead and close these files. In our project pane over here on the left, I'm going to right click on my package here, com goobar.io 8340. And I'm going to go up to new and select new package. And I'm going to name this package API and hit OK. Now I'm going to right click on that new API package and go to new Kotlin file or class. I'm going to select interface and I'm going to type open weather map service and hit enter. So now by default, this should create a new Kotlin interface called open weather map service. And this is going to serve as the basis for our retrofit API service. So let's go ahead and create that first. Actually, before we create our first interface, or our first method on the interface, excuse me, we want to create a function that will return to us a valid implementation of this interface. So this will be the actual service implementation that we will use to load our data. So to do that, we're going to create a top level function in this same file here. I'll type fun, create, open, weather map service, and it is going to return an instance of our interface. So I'll type open weather map service here, and then add my block body. Within this, I'm going to create an instance of the retrofit builder. So I'll type val retrofit equals retrofit dot builder. If it asks you to import retrofit, go ahead and do that. And then now we need to specify the base URL for this retrofit endpoint. So this should equate to the base URL of whatever API service you're using. So for us, that base URL is going to be http://api.openweathermap.org. And then we'll go ahead and add a .build call to the end of this. So that will give us a created retrofit object. And now we can use that to create our service implementation. So we will return retrofit.create open weather map service class.java. So now when we call create weather map service, it's going to create an implementation of our API, and we'll be able to use that API class to actually return the weather data. So let's go ahead and get started then on implementing our service. To start, we're going to come back over to API on the project pane, and we're going to create a new Kotlin file, and we're just going to call this file current weather. Now within this, we are going to define the models needed to model the API response from the weather endpoint at Open Weather Map API. So to do this, follow along here. We're going to create a data class called forecast that will hold a temp value, and that temp value will be a float. So this is going to hold temperatures for us. We're going to create another data class called coordinates. This is going to hold the lat-long coordinates, which will be important because we will need those when we're using the one-call API for the 7-day forecast. So this coordinates class will take a val called lat of type float and a val of type, or a val called lon of type float. So this will hold our lat-long coordinates. So now we're going to create a data class. This time it's going to be called current weather. The first property on this is going to be called name string. This name is going to be the name of the location that was passed in, which is a little counterintuitive, but it'll help us display the name of the location in the current weather screen. Then we're going to make use of our coordinates class. So we're going to create a property called coord, which is short for coordinates, and it's going to be of type coordinates. And then now this one's going to be a little bit trickier. We're going to define a property called val forecast of type forecast. However, the API response for this class does not have a forecast property. Its name is actually something very odd, that it's named main, but within that main object, it has things like the temperature. So in cases like this, where you want to have an API and properties that are named more semantically correct or just more intuitively on the client side, we can annotate this property so that Retrofit knows how to parse it, but we can call it whatever we want. So to do that, we're going to type at field, which will apply this annotation to this field alone, colon, JSON, and then we're going to say name equals main. And then if it prompts you, go ahead and import the JSON annotation. So now what this is saying is that there is going to be a JSON response field called main, and we want to map that into this forecast property. So now that we have our API model defined, we're going to go back over to our Open Weather Map service. And now we can go ahead and define the first method on this service, which will correspond to the Open Weather Map /weather API. So to define a new retrofit endpoint method, we'll start off by defining the get annotation to specify that this is going to be a get REST request. So within this get annotation, we're going to define the path to the endpoint that we want to use. And the way that these will get built up is it'll take the base URL that we defined above, which was api.openweathermap.org, and then it's going to add this bit for each individual endpoint. So for this endpoint, we're going to use /data/2.5/weather. Now we can go ahead and define a method as we normally would. So we'll type fun. We'll call it current weather. And now we need to specify what parameters we want to include along with this method. These should map to the query parameters that we were using in our browser and that are present in the documentation. So the first query parameter will be the zip code. So we're going to use the @query annotation here. And within the request that's going out to the endpoint, we want this to be called zip. So we'll pass zip in as within the query annotation. And now we need to define the name of the parameter, and we can call this parameter anything we want on the client side. So we'll call it zip code, and it'll be a type string. For our next parameter here, we're going to do @query units. This will allow us to specify what units we want it back, because we probably don't want it in Kelvin all the time. And I'll just call this parameter units, and it'll be a type string. And then the last parameter, it needs to be the app ID, which is that API key that we got when we created our Open Weather Map account. So this time again, @query app ID, and we're going to call this API key, and again it is of type string. Now we need to specify the return type. So this has so far specified the request. Now we want to define how the response will come back. So we're going to use that retrofit call class to wrap this response. So we'll define call, and then we need to tell it what type to expect back. And so we want to expect back one of our current weather models. So now when we call this method, we should be able to actually get back valid weather data for the zip code that's passed in. So now let's go make use of this. Let's open up our forecast repository. And then we're going to go to load current forecast here. And we're just going to delete everything that we have there currently. So now let's go ahead and kick this off by creating a call class that represents that request to the endpoint we want. So we'll type val call equals create open weather map service dot current weather. We will pass in the zip code. Eventually, actually, then we will pass in the units here. And these units, for now, I want to use Fahrenheit. So I will pass in imperial. And then eventually we need to pass in our API key. So I'm just going to put API key here for now. So then how do we actually use this call to get a response back? Well, as we saw in the lecture notes previously, we can type call.enqueue, and then we need to pass a callback in here. So we're going to basically create an anonymous inner class here. So this will be an implementation of the callback without any actual name. It'll be used just in this location. To do that, we'll type object : callback. Now it might prompt you for importing what callback you want to do. We want to make sure that we use the retrofit version of this callback. As you can see here, there are a lot of different callbacks available. The retrofit one on my screen is at the very, very bottom of this list. So I'll make sure I import the proper retrofit callback. Now that callback is going to hand us back a current weather, so we'll put that within the braces. And then I'm going to add my open and closed curly braces here. And now when you get this, you should see a little red underline underneath the object. Basically, this is indicating, hey, you have not implemented all the methods we need. So to fix that, you can put your cursor on the object with the underline and hit Alt-Enter, and it should ask you if you want to implement the members. And you can hit Enter, and then you can highlight both methods and hit OK. And it will generate the implementations of the onFailure and the onResponse. So now we can handle both of these cases. So for now, if we get a failure, I'm just going to log it. So I'm going to type log.e. Log.e will use the default Android logger to just log that issue locally. For my tag, I'm just going to pass in forecast repository class.java.simplename. And I'm going to just pass a message of error loading current weather. And then I will pass along the throwable. So this will give me a little bit of information to start debugging if we have any problem here. Now the more interesting case is in onResponse. So this is the case where theoretically things have been loaded correctly for us. So let's go ahead and think about how we can handle this. So I'm going to type val weather response equals, and then we'll use the response body dot body. That dot body call will essentially unwrap it from the response call. At this point, we can check if that is null or not. So we can say if weather response does not equal null, then we could update our current forecast data. Now you might see a little bit of an issue here. We have current forecast, which is expecting a daily forecast, but we have our weather response, which is a current weather object. So we need to come back up to the top of our repository and update current forecast to take in that new current weather model that we defined. So here where it says current forecast, let's update this to underscore current weather of type current weather. And then we'll update the public property as well to say current weather. So if we scroll back down here now to onResponse and we update this to underscore current weather, now everything in our repository looks good. Let's just jump over then to current forecast fragment and double check everything here as well. And sure enough, we see that we have an issue here, which is that the forecast repository.current forecast is not available anymore. So if we update this to say current weather, we'll then see we have yet another issue. And ultimately what's going to happen here is we're going to need to update our adapter as well to account for this new data. So for now, we're just going to let this error sit. And we're going to go back over to our forecast repository. Now, if you remember correctly, if we look at our call class here, or excuse me, our call statement here, we passed in a temporary string for our API key. So now we're going to actually define our API key, and then we're going to update our project so that we can use our key without having to check it into our GitHub repo. And the reason we're doing that is because your API keys are meant to be private. You don't want to share them like I'm doing here in this demo with all of you, because theoretically you open yourself up for someone using your key when they shouldn't be. So for us, what we're going to do is we're going to come to our left-hand side of the screen here, again in our project pane. And we should have at the very bottom a local.properties file. If you don't see local.properties in your project, go ahead and create it. To create it, you would simply go to the root directory of your project, right click, go to new file, and you could enter in local.properties. Within this local.properties file, we're basically going to create a new build configuration property called open weather map open underscore weather underscore map underscore API underscore key. And then I have placed in my API key right here. So what this will let us do is pull this value in from our Gradle file and use it at compile time so that we can get access to that. And by default, this local.properties file should not be checked in to your project on GitHub. In fact, if you look in the .gitignore file, which Android Studio should have created for you, we should see that it is explicitly ignoring the local.properties file. So it makes it perfect for this use case. So within your local.properties, add this open weather map API key property name and pass in your API key. Then we're gonna open up our app build.gradle file. Within this app build.gradle file, we're gonna come up here to the default config block. And we wanna add a property for configuring this API key property. Now, the first thing we need to do is go to the very top of the Android block, and we're going to type def local properties equals new properties. Then on the next line, we're going to type local properties dot load new file input stream root project dot file local dot properties. So what this has done is basically created this new local properties variable, and it's going to load any information in from that local.properties file that we just used. And now, just as a side note, this build.gradle file, the code we just wrote probably seems very familiar if you're used to Java. This language that's used for Gradle files is actually called Groovy. So technically this is a whole separate programming language that we just used. So now within just this one Android project, you can say that you have worked with JSON, Kotlin, XML, and Groovy. So that's pretty cool. It's 4 languages in one project. So now once we've defined this local properties configuration, now we'll come back down to the default config block, and we're going to make use of that. So we're going to define a new configuration property by typing build config field. This will let us define a new field on our build config class. It's going to be of type string, comma, and we want it to be called open weather map API key, comma, and then this part is a little bit tricky because we have to do a string substitution to pull that file in and parse it correctly. So to do that, first we're gonna type double quotes, and then I'm going to do a backslash double quote. So that has escaped the quote, so it should make it into the final string. And then now I'm going to do a dollar and then open and close curly braces. So now this is going to do a string substitution within this. And now out on the other side of those brackets, we're going to do another backslash double quote just to finish escaping that. So now everything should be even on both sides, and we can worry about implementing what's within these curly braces. So within the curly braces, we're going to type local properties. We're going to do open and closed brackets, and we're going to pass in the same key name that we used in the local.properties file. So open weather map API key. So now once we've finished adding this build config field, we should be able to do a git sync again, just to make sure it regenerates the property. Then we can come back over to forecast repository, and where the API key used to be, we'll type build config.openWeatherMap API key. And so that's going to bring that API key in for us and allow us to pass that along to our API requests correctly. So now it's time to go ahead and update our UI to account for this new current weather object. So we'll go back to current forecast fragment, and we're going to go into the layout XML. And what we're going to want to do is actually remove the list from the layout. So we'll find this recycler view here, and we're going to remove that. If we go back to the design view, we'll see here that all we have now is the floating action button. So now what we're going to do is just come over here and drag a text view into our layout. I'm going to constrain it to the top and left. We'll just add a quick 16 dp margin to the left and top as well. And we're going to just call this for now location name. And then if you really wanted to, you could come lower in the attributes panel and maybe update the text appearance to something like large. So now we'll go back over to current forecast fragment, and we're going to update our repository interaction here. So let's start by looking at our observer. We're going to update this to be current weather observer. Instead of a daily forecast, it's going to pass us back a current weather object. Instead of forecast item, we will just call it weather. And now instead of updating an adapter, we're going to type location name.text equals weather.name. Now, you might notice we don't have a location name property yet. So we need to go back and update our view properties here. So first, we'll notice we have this daily forecast list, the layout manager, and adapter. All of that stuff can go now. And now up here, right below view, we'll type val location name text view equals view find view by ID r.id.location name. And now back down in our observer, location name resolves correctly. So then our forecast repository, we want to make sure we're calling current weather.observe, and we will pass in our current weather observer. So again, just to review, forecast repository.currentWeather is a live data. It hands out current weather values anytime we have loaded that new data. When we get a new current weather object, we're going to update this text view to show the name of the location we just loaded weather for. Now let's go back over to fragment_current_forecast. So if we click on this text view, we're going to work on cleaning this UI up a little bit so we can display more information about the current forecast. So here, we're going to come over to the right, and in the common attributes section, under the tools text icon, that's the one with the little wrench by it, I'm going to just type Seattle here, since this is going to show our location. And then under the regular text property, I'm just going to delete that for now. Now I'm also going to come down here and I'm going to add another new text view. This one I'm going to name temp text. And I am going to constrain this so that it is right along there with the location name. Now we'll go back over to current forecast. We'll get a reference to that temp text property, val temp text colon text view equals view dot find view by ID r.id.temp text. And then now again, we'll come back down to our current weather observer and we'll type temp text.text equals format temp for display, and we will pass in weather.forecast.temp, comma, temp display settings manager dot get temp display setting. So let's just one more time quickly review. When current forecast fragment is created, it is going to listen for changes in the saved location. Anytime the saved location is updated, it's going to make a call to forecast repository.load current forecast and pass along the saved zip code. When the repository returns its data, we're going to update the UI to display the location name and the temperature. So let's go ahead and try to run this and see how our UI looks now. So I'll click run, and then I'll just open up my emulator here. And you likely will see a crash immediately. The reason for this crash is because we have updated the permissions and we are now actually making network requests. We have internet permission. So the easy way to fix this is to just make sure you delete your app once before you try and actually load real data for the first time. And then just go back to Android Studio and redeploy the app. And so you see now here, we've redeployed the app. You can see that we have this empty text view property here. So let's go back to Android Studio real quickly and just fix that. So go to our current forecast fragment. We'll click on text view. We're going to make the default text be blank, and the sample text, we're going to make it say something like 72.0 degrees. There we go. So now we have a good idea of what our UI will look like, but it won't display on the screen. Once again, let's rerun this. We'll switch over to our emulator. And there we go. Nice blank screen. And again, we don't have a saved location yet, so all these screens are blank. So now let's go ahead and enter 98119 for Seattle zip code here. Click submit. And once again, we'll see an error here. So now on this error, if you come into your logcat and you find the error, you should see something that looks pretty similar to this. If we make this a little bit bigger here, should see something that looks like unable to create converter for class current weather. So now what this is telling us is that our retrofit instance here, this implementation of our API service, doesn't know how to convert the JSON response into our Kotlin classes. So this is where that Moshi converter comes into place. So we'll come right below base URL here and type add converter factory, And then we'll pass in Moshi converter factory.create. Now, once you've done this, go ahead and do a rebuild on the project. And then once that's done, go ahead and redeploy. And then we'll switch back to our emulator. And now we see that we are having Seattle displayed out to the screen and real temperature data. So this is the first instance in our course so far of actually loading real live data from an API out there in the wild. So now let's jump back over to Android Studio. And we can continue on. And now we can start loading our weekly forecast data. So let's just clean this all up a little bit. Close all the files. And we're going to start by cleaning up our current daily forecast class here. We're basically going to create a new proper version of this class. So for now, we'll right click on that. We'll click delete. We're going to click unsafe delete here because we know there's other places in the code currently using this, and we'll update those later. So we're just going to hit OK. So now we've gone ahead and deleted daily forecast. So now we're going to come up here to our API package again, right click on this, go to new Kotlin file, and we are going to create a class, or we will name the class or file weekly forecast. And like we did for the current weather, we're going to define several new models that will build up the response for our weekly forecast data. So the first one will be called data class weather description. It's going to have a main property called string, and it's going to have a val description property of type string, and it's going to have an icon property of type string. Then we'll create a new data class called temp. This is going to have a min property of type float and a max property of type float. Then we will create our new daily forecast class. So data class daily forecast. We're going to create a date property of type long, but because the JSON response names it differently, we need to once again use @field: JSON name equals DT. So in this case, DT stands for date time, but we want to refer to that property as date because it's more specific. Then we'll define another property here called temp. That'll be an instance of the temp class we just created. And then finally, val weather, which will be a list of the weather description classes that we just created. And finally, the very last thing, we will create a data class called weekly forecast, which will take a list of daily forecast items. So now this weekly forecast object will be the response for our weekly forecast endpoint. So like we did before, let's now go to forecast repository, and we will update our live data to account for these new API models. So now instead of a list of daily forecast, our live data will return a weekly forecast. There we go. So now let's scroll down to our current load weekly forecast implementation. And we're just going to delete all of that because we are going to be updating that very shortly. Now, before we go ahead and implement this method, we're going to update our UI to account for this new weekly forecast item. So we're going to scroll down to the list items that we have for our weekly forecast list. And we're going to select item daily forecast. Excuse me. And the first thing we're going to want to do here is add a new text view. This text view is going to take the date for each individual daily forecast item. So we're going to give this the ID over here in the attributes pane, and its ID is going to be date text. We will constrain this so that it sits to the left, just like, or right to the left of the temperature there. Then we want to select the temperature text view, and we're going to come to the right-hand side and we're going to delete its constraint on the bottom of the parent because we want to update these so that they're nice and centered. So now we're going to again click on our new text view. We're going to constrain it to the bottom of the parent. We're then going to select both of them, right click, go to chains, and click create vertical chain. So now what that's going to do is kind of nicely, evenly space them out here in that list item. Now we're going to open up daily forecast list adapter. And we have several issues here that we want to fix. So first off is we need to update the import for daily forecast because we deleted the old one. So just put your cursor on daily forecast and hit Alt Enter and click import. And so that should fix a number of the issues. Now we want to come to the forecast view holder and we want to add a reference to the new date text property and then update how we're binding that data to the UI. So to start, we'll come down here below description text and type private val date text equals view dot find view by ID. It's a text view, so we'll specify that type in the brackets, and then we'll pass r.id.dateText as the ID. Now, down here in our bind method, so we no longer can pass dailyforecast.temp. What we need to do is type dailyforecast.temp.max. So now our temperature text will be updated properly. For description text, we're going to use dailyforecast.weather. We're going to get the 0 element from that weather list, and then we're going to pass in the description. So we will get the first weather description, and we should always have at least one, and we'll pass that description into our text view. And then finally, the new date text here. So we're going to type date text.text equals, and then we're going to want to format this text in some way that is understandable and meaningful to the users. And one way that we can go about doing that is to use a date format. So I'm just going to scroll up to the top of the file here, and I'm going to define a date format that we can use to format dates into something we can read easily. So I'm going to type private val date format equals simple date format. Simple date format is a common Java class for formatting dates. And here we've passed in a pattern that says we want our dates to be formatted so that we see the month, the date, and then the year. So now we can use this date format to format the timestamps that we're getting back from the API. So we'll type dateText.text equals dateFormat.format. And then we need to pass in a date object. So we will create a new date object. And when you import this, make sure you import a java.util date instead of java.sql date. So here we have created our new date. And what we want to do is pass in daily forecast.date. And then there's one little caveat here. The date class expects this to come back in milliseconds, and the API is giving us back seconds. So we're just going to multiply this by 1,000, and that'll make sure that our date is going to display properly in the UI. Now let's go to weekly forecast fragment and update our UI here. So the first thing we're going to need to update is our observer. And so again, we're not doing a list of daily forecast items anymore. We're getting a weekly forecast item back. So we'll update our observer. And now down here, before we get to that, we're going to rename forecast items to weekly forecast, just so it's a little bit more clear. And now we'll pass in weekly forecast.daily. And that'll pass in that list of the daily forecast items to our adapter. And now, also just while we're here, we see our call to weekly forecast.observe, and we're passing in this. If you still have a this there, you might see this little warning that says use view lifecycle owner instead. So while we see this here, we'll just update that to say view lifecycle owner. It's a nice little hint there from Android Studio for us. Now if we come down here to show forecast details, we also are going to want to update how we are passing this data in. So again, let's update the import for daily forecast. And then now we're going to need to update how we're getting the temperature and the description. So let's create a new property for the temperature. So we'll say val temp equals forecast.temp.max, and we'll say val description equals forecast.weather brackets 0 to get the 0th element of that array dot description. And now we'll come back down here to our call to the action, and we'll just pass in the temp and the description. So now it's time to actually go back into our forecast repository, and we want to update the implementation of load weekly forecast. And before we can do that, we need to add the new method to our retrofit endpoint. So we'll open up open weather map service one more time here. And now below our first method, we are going to create a new method here. So again, we'll type at get. This time the endpoint will be /data/2.5/1call. We're going to name this function 7-day forecast. And now it's going to take a number of parameters. So the first one will be at query lat float. Then we will have at query lon float. Next up, we need to define a property called exclude. And then we will call this again on our client side exclude as well. And that is going to be of type string. Next up, we will do the units and we will do the app ID. And since these are the same as our previous query, I'm just going to copy and paste these to save a little bit of time. And then we'll just double check these, make sure they're spelled correctly, have the proper types. I see here I have a typo. I need this to be exclude instead of exclude. So there we go, I've updated that. So now in our forecast repository, we can make use of this new call. Now, if we go back to the newly implemented method for a second, you might notice that it doesn't take a zip code. It takes a lat long. This is just a limitation of the free endpoints on this, but it's actually a good learning opportunity for us because we're going to see how we can chain together two asynchronous calls. So what we're going to do is make a call to the current weather endpoint because it will return us back a lat long. We'll then use the lat long to call the second endpoint and get the 7-day forecast. So to start off, we'll type val call equals val call equals create open weather map service dot current weather. We'll pass in a zip code. We'll pass in imperial for our units, and we'll pass in build config.openWeatherMap key. And then just like before, we're going to do the enqueue call. So I'm just going to copy and paste this to save a little bit of time. This time I will change the error message just in case we get an error. It'll be a little bit more descriptive. This time it's going to say error loading location for weekly forecast. And so now down here, if we get the weather response, instead of updating the live data, we are going to load 7-day forecast. So within this, we'll then make another call. So this will be val forecast call equals create open weather map service dot 7-day forecast. And this time we're going to say lat equals weather response dot cord dot lat. Lon equals weather response cord dot lon. Exclude equals current minutely hourly. So this endpoint actually can return you back current weather, minute by minute weather, hourly weather. We only want the 7-day forecast, so we exclude all of the rest of that stuff. For units, we're going to pass in imperial once again. And then, of course, one last time here for API key, we're going to use build config.openWeatherMap key. So we have that new large call created. Now we need to call enqueue on it. So forecast call dot oops. So you notice we couldn't call forecast 7-day forecast dot enqueue. It's because we forgot the return type back here in open weather map service. So we'll come back to our retrofit implementation interface here, and we'll make sure we have a return type here of call weekly forecast. So now if we come back here, we should be able to say forecast call dot enqueue object retrofit to callback of type weekly forecast. We'll make sure that we implement both of the methods there. So this time on an error, we'll type log.e forecast repository class.java.simplename error loading weekly forecast. Now down here in on response, we'll type val weekly forecast response equals response.body. If weekly forecast response does not equal null, weekly forecast dot value equals weekly forecast response. So that will update our live data and ultimately update our UI when we have loaded that forecast. So now we will rerun this. Here we see once again in current forecast fragment, we see we have one more daily forecast import we need to update. So there we go. However, if we actually think about it now, within current forecast fragment, we're not showing a list of items. So we actually can't ever even get to show forecast details anymore. So we're actually just going to remove show forecast details from current forecast fragment. Now let's rerun this once again. Switch over to our emulator. And now we see that we have an empty screen here on the week. So something is not quite going correctly here. So after some quick debugging, I found the issue in my code, which was another typo that I didn't notice before. But back in the Open Weather Map service, you need to make sure that the long property is LON, not LONG. So now we'll run this one more time. And now we see that we have weekly forecast data. And we see that our dates are nice and human readable and go out for the next 7 days or so. So now let's work on making this piece of the UI look a little bit better. We're gonna jump back over to Android Studio. And now we want to work on loading image data using Coil. So we'll jump over to Chrome one more time here. And we're going to search for Android Kotlin Coil. And we should see this Coil-KT image loading for Android backed by Kotlin coroutines. So this is the image loading library we're going to use. And we can see here, it shows you right at the top the implementation line you need to add to your build.gradle file. So I'm going to copy that, go back over to Android Studio, and I'm going to open up my apps build.gradle file, scroll down to the bottom below the Retrofit dependencies, and add that new dependency on Coil. So now the first place we want to add an image to is the list items in our weekly forecast list. So let's open up item daily forecast, and I'm just going to close the rest of the files here. Whoops, item, there we go. So we have item daily forecast open and nothing else. So what we want to do is add a new image view to this. You want the image view to sit on the left hand side of the screen. So what I want to do here is grab the temperature text view here, which is what my constraints are based off of. And I want to just delete that left constraint. And then in fact, I'm just going to move that whole thing over to the right. And because the other two text views are connected to it, they all move. So now that gives me room to add my image. So if I click on the widgets in the palette here, grab image view and drag it over, it's going to ask me to pick a resource. I'm going to type cloud, and I'm going to use this cloud image as the placeholder for now. And so you should see by default, it's going to be this nice little tiny cloud icon. So I'm going to click on that once again. In the attributes panel on the right hand side where it says ID, I'm going to update the ID to be forecast icon. I'm going to update the layout width to be 56 dp and the layout height to be 56 dp so that it's much larger and fits the screen a little bit better. Then I'm going to constrain it to the left of the list item, to the top, and to the bottom. Then I'm going to give it 16 dp margin on the left, top, and bottom as well. And we should end up with this icon that is roughly centered vertically and is pushed over towards the left. Now I'm going to grab my temperature text view again, and I'm going to constrain it to that icon. And I'll just add some margin so that again, things are nicely spaced out. So now what we want to do is go into our adapter, go into the view holder specifically, get a reference to this view, and load the weather icon into this image view. So to do that, let's open up our daily forecast list adapter. I'm going to scroll up to the daily forecast view holder and create a new property for the image view. So private val forecast icon equals view dot find view by ID. This time it's going to be an image view. And so we'll likely need to import that for the first time. And for an ID, I'll pass r.id.forecast icon. So now we've got the icon. How do we load the URL into this? Well, if you remember from our weekly forecast model, we have this weather description. So anytime we have a weather description like cloudy or light rain, we get a description and we also get an icon. And that icon is a simple identifier. If you actually look at the API documentation for Open Weather Map, you can actually see what this looks like. There is a section on icons. Let's find it here. Oh, it might be actually in the OneCall API here. There we go. If you just search for icons in the API documentation, there's a section here that says how to get icons. If you click on that, it pulls you to this other page here. And it basically shows you that these day icons, these night icons, they all have this little 3-character ID essentially. This is what we get back in that icon property. So when we have that ID, we can basically place it into this predefined path and use that to load the image icon. So that's how we're going to load these icons using Coil into our image view. So if I go back into Android Studio, back to my daily forecast adapter, I'm going to start off by getting the icon ID out of that daily forecast item. So I'll type val icon ID equals daily forecast dot weather 0 dot icon. So I'm going to grab the first weather description, which is the primary weather description, and grab the icon ID. And then I'm going to type forecast icon, which is our image view, dot load. And then we're going to pass in a string here. And that string is going to be that predefined string that the API uses for the icons. So that is http://open weathermap.org/img/wn/ and then we're going to do a string substitution here. So I'm going to do $ open and close curly brace, and I'll pass icon ID inside of those braces. So it's going to substitute in that code. And then to finish it off, I'll do @2x.png. So this is going to go to that URL, find that image, and load it into our image view. So if we go ahead and run this now, when we open this up, we should see those nice looking icons there associated with the weather that it's displaying. So that has been basically the simple process of how you load up an icon. Now, as part of the homework assignment for this week, you're going to be asked with loading the icon for the current weather string as well. And so the same process will apply. You're going to grab the weather icon if it's available. You're going to use that predefined URL, and you'll use Coil to load it into your image view in the same way. So check the assignment details for the more specific instructions about which screens and which icons you'll need to load. Now, one last thing before we end the demo for the week. As last week we were talking about material design, we talked about the app bar, we talked about our bottom navigation view. In regards to the app bar, we used a toolbar to basically serve as our app bar. And we kind of left it at that because we didn't want to complicate things too much. However, with that simplicity, there's one thing that we sort of missed, which is that the styling of this app bar isn't quite right. You'll notice the bottom navigation view has a little bit of shadow applied to it. And same thing with our floating action button. There's shadow there, there's elevation. Elevation is kind of a hallmark thing in material design. However, because of the way we implemented our toolbar so far, we don't have that shadow. It's just flat, and it's subtle. It might not even come across in the emulator here, but you likely notice it on your screens. So we're just going to make one more material design update to our app to continue making it look and feel like a modern Android application. So if we go back to Android Studio, we're going to go open up activity main.xml. And we see here we have our toolbar. And we don't have any type of elevation applied to this toolbar. Now we could explicitly add elevation to the toolbar, which would get largely the same effect. However, we'd have to manage that manually, and sometimes those rules can change a little bit. There is a default component that we could use that'll actually manage that elevation for us on its own, and we don't have to think about it. And it's actually conveniently called app bar layout. So that makes a lot of sense since it's representing our app bar. So to use the app bar layout, I'm just going to type an angle bracket and just start typing app bar layout. And it should automatically pop up for us. For the width, I'm just going to type match parent. For height, wrap content. As an ID, I'm going to use app bar layout. And then I'm going to close that off so that I can add the toolbar inside of it. So I'm going to copy the toolbar, hit delete, and then paste it back inside of the app bar layout. And now, because the toolbar is not the top level element anymore, I'm going to take the constraints from the toolbar and just move them outside to the app bar layout. So now the app bar layout is constrained to the top, the start, and the end of the parent, and the toolbar is just wrapped by the app bar layout. And now the one last change to make is go down to the nav host fragment, and it likely has a constraint of constraint top to the bottom of toolbar. We're just going to update that to be bottom of app bar layout. So to kind of double check your work, if you come back to the design view here, you should see the same rough layout here. You have an app bar layout at the top and the nav bar, the nav host there in the middle. So if we run this one more time, we can just double check our work here. And there we go. So it's very subtle, but you can now see that our app bar has elevation to it. And as you scroll content, it's much more noticeable. You can see that the content really looks like it's going underneath the app bar, which sits at a higher level or higher elevation, which is what is expected in material design. So that has been it for this week. We've gone through a lot here. We've loaded data. We've now saving our location. We learned how to load images. In the homework assignment, you'll be asked to sort of build on what we've done here, and then also add a couple of these things in some additional places for some extra practice on how to load images or how to grab extra information out of the API response. It's all going to be things that we've already walked through here. You'll be applying them simply in an additional location. So check Canvas as always for the details on the assignment, and reach out to me if you have any questions, and I will see you all in our next lecture.